Okay, so this is the first question in the final of Physics 101 in spring 2018. You're asked to consider a ball that's basically hitting a floor and then just reflecting back, but it actually falls a distance of 7.2 meters, and next time it only rises to 5 meters. So that we call this H and this one H prime. The ball remains in contact with the floor so basically its elasticity gives it a finite time for reflecting from this floor. Okay, so find the magnitude of the impulse delivered to the ball by the floor. So what do we actually need? We need the impulse. Impulse is F times delta t, right? But that's also equal to the change in the momentum of the ball. So if the ball hits with some velocity v and reflects back with velocity v prime, the magnitude of this is going to be mv plus v prime. This is going to be p final minus p initial, but initial and final velocities after this collision with the floor are in opposite directions, so I need to find the velocity just before the ball hits and just after it's reflected, and I have to basically add them up. And how do I find v and v prime? Energy is conserved during the fall or just after reflection, right? Because air drag is negligible. So I'll just say 1/2 mv square must equal m times g times h. Similarly, 1/2 mv prime square will be m times g times h prime. So m's cancel. V is square root of 2gh. Similarly, v prime is square root of 2g h prime. Let's put in the numbers. A is going to be square root of 2. G is given as 10 meters per second square, 2 times 10 times. H is given as 7.2. So it's going to be square root of 144, which is going to be 12 meters per second. Similarly, V prime is going to be 20 times H prime is 5. It's going to be 10 meters per second. Overall impulse, the magnitude will be just F times dt will be equal to m. What was m? M was given as 0.5 kilograms. So m v prime plus v is going to be 1 over 2 times 12 plus 10 is going to be 11. And what's the unit for this? I can either use momentum units, which would be kilogram times meter per second. Just as well, I could write this as the unit as Newton times second. So that's part A. We've done this. What's part B? What's the magnitude of the average force exerted by the floor on the ball? So impulse is F times delta T. That's going to be the average force. I should have written it from the start. F average will be impulse divided by delta T. So it's going to be 11 divided by 0.1, 110 newtons. We've also done part B. How much energy is lost during the impact? Well, before the impact, this ball is free falling. After the impact, it's again doing motion which conserves energy. So the only loss happens during the collision with the floor. Delta E would be E final minus E initial. But I'm actually asked to find the energy lost. So that's going to be mg h minus h prime. M is 1 over 2, G is 10, 7.2 minus 5.0 is going to be 2.2. So this is going to be 11 joules. And that is the final part of the question, which was actually quite simple.